Section 7.1 Interactive Assignment Objective 4. Suppose the birth weights of full-term babies are normally distributed with a mean 3,600 grams and standard deviation is equal to 405 grams. We're going to complete parts A through C below. So the first thing we want to do is we want to be able to draw a normal curve with the parameters labeled, and then we're going to choose the correct graph below. Okay, so now the normal curve is symmetric about its mean. The normal curve has inflection points with the mean minus the standard deviation and the mean plus the standard deviation. So for this problem, we want to identify the values of the mean and the standard deviation. So again, remember here that we have the inflection points at those. So therefore, there is our inflection points on our graph, and there we have our mean. So let's identify the mean and the standard deviation. Well, the mean is 3,600 grams, okay? And we can see that the standard deviation is given by 485 grams. All right? So what we're going to do is we're going to determine the location of the inflection points. So the first thing we're going to do is we're going to take that mean, which is 3,600, and then we're going to subtract the standard deviation to get the value of 3,115. And then we're also going to do the following. We're going to take the mean again, and now we're going to add the standard deviation. So we take the mean of 3,600, and then now add 485, and now that gives us another point, which is the inflection point of 4,085. Okay, now the next thing that we want to do is now we want to be able to draw our bell curve. So you want to get in the habit of knowing how to draw your bell curve. So here's our bell curve. Okay, and then we're going to draw our bell curve here that is symmetric. Okay, and so therefore we know that this is going to represent our mean. So our mean is given by 3,600. Okay. And now we know that it's one standard deviation above and below the mean are our inflection points. So writing out our inflection points, we know that we have an inflection point over on this side, and then we have another inflection point on this side, and then we can go ahead and then write down our values. So we know that the one standard deviation below the mean is 3,115. And the one standard deviation above the mean is 4,085. Okay, and therefore, again, we know that this represents x. Again, this is an inflection point here. And then we also have one located over there. Okay, so let's go ahead and then check our result. So we need to pick which graph represents our graph. So here we have the mean of 3,600, there's 3,115, 4,085, and it looks like that is the one that should be our answer. So we should see that A represents our answer. So looking at that, that is the result. Okay. All right, now the next question is asking us, shade the region that represents the proportion of full-term babies who weigh more than 4,570 grams, and then we're going to choose the correct graph below. Okay, so first thing we need to do is for the given normal distribution curve, the area under the curve to the left of the values shows the proportion of full-term babies that weighs less than that value, and the area under the curve to the right of the value shows the proportion of full-term babies that weigh more than that value. Now, what we want to do is we want to shade the region that shows the full-term babies that weigh more than 4,570 grams. And it is necessary to shade to the right of 4,570. Okay? So, let's go ahead and then draw our bell curve. Well, we know that we have our bell curve. Okay? And with our bell curve, we know, again, that we have a mean at 3,600, okay, and we're looking for more than 4,570. Now, going back to our previous step, we can see that the inflection point on the left represented 3,115, and the inflection point on the right represented 4,085. Okay, and so what we're doing is we're focusing on where it's more than 4,570 grams. So what we're going to want to do is we're going to want to find out where that value is located, which is to the right of this number. So we can see that to the right of this number we can have 4,570. Okay, and then what we want to do is we want to shade everything to the right of that. So that means we want to shade everything here to the right of this graph, because then that's going to represent everything that's more than. Okay, now I also want you to notice that 4,570 is 2 standard deviations away from the mean. Okay, and what I mean by that is, okay, so if we added 3,600, okay, if we added the standard deviation of 485, okay, that's 1 standard deviation away from the mean. And if we add another 485, then that would give us 2 standard deviations away from the mean. And so therefore, that is our result. Let's go ahead and make sure that we can check on our graph here. So if we look here, we can see that this graph here is 2 standard deviations away from the mean, and we're shading that to the right. Over here, this would represent 1 standard deviation from the mean, so we need to be careful of the fact that this is 2 standard deviations away from the mean. So again, we're shading it to the right. All right, last question. It says, suppose the area under the normal curve to the right of x is equal to 4,570 is 0.0228. We want to provide an interpretation of this result. Okay, so that means that for the following, I'm going to go ahead and copy this graph. Okay, so if I copy this graph, okay, what it's saying here is the following. It's saying that this graph right here, or this shaded area, okay, represents a probability of 0.0228. Okay, so what does that mean? Well, that means the following. It says that the characteristic of this described by the interval of values is full-term babies that weigh more than 4,570 grams. So let me move this graph down a little bit further here. The probability is 0.0228 that the birth weight of a randomly chosen full-term baby in this population is more than 4,570 grams. So if we take a look at our result, we can see that we have more than, and that gives us the result.